The next activity is about a servo motor. This special type of motor is used worldwide as it can be controlled the speed, the torque, and the position easily. There are three wires used to control it. The red one is connected to 5-volt. That is, it should be connected to Raspberry Pi pin number 2. The brown one is simply the ground, so it should be connected to the ground of the Raspberry Pi. And the last one, the orange one, it will be connected to GPIO 17, or you can say pin number 11. The pulse width modulation signal from this pin will be sent to control the position of the servo motor by adjusting the duty value, as shown in the table below. If we set the duty to be 7, so the servo will rotate to the position at 90 degrees. But if the duty is set up to be 9.5, which is between 7 and 12 exactly, then the angle of rotation will be exactly between 90 and 180, that is 135 degrees. But then if the duty is set to be 0, then the position remains the same. Let's explore the Python code. Begin with, we import two libraries, rpy.gpio and time. The next, we have to set up the way that we call the pin number. Last time, we used BCM. This time, we use the board. You can always find more detail about this in the appendix. After I set up my mode to be the board, then I set up my pulse width modulation to generate 50 Hz, and it is generated from pin number 11. If you are using BCM, we will call this pin as GPIO 17. After that, we set the pulse off by the command servo1.start. We wait for 1 second and then start rotating 180 degree in 10 steps. That means each step represents 18 degrees. So we define the first duty to be number 2. As long as your duty is not yet 12, we do this loop, servo1.change duty cycle to be the duty that we have, which is 2 for the first time, and then wait for 1 second and increase the value of duty by 1. In the next loop, your duty now becomes 3, so change your duty cycle to be 3, that means 18 degrees, and then wait for 1 second and increase your duty again to be number 4. Keep repeating like this until your duty becomes 12, and then wait for 1 second. We are about to turning back to 90 degrees, so we change the duty cycle to be number 7, that means 90 degrees. Wait for 2 seconds, and then we change the duty cycle again to be number 2, that represents 0 degrees, and wait a little more, 0.5 seconds, and we add this line, servo1.change duty cycle 0. We know that 0 here represents no change, so it will keep the position. Last time you said that you are using number 2, that means it is 0 degrees, so it stays still, not move. We set up this line here because we don't want to see a jitter. Your servo motor will stay still, not move at all. We recommend you to use this line all the time. And finally, we need to clean things up. So we set the servo number 1 to stop and clean up all the communication port by gpio.cleanup and print out goodbye. The next Python code. This code is similar to the previous one, but we just add one more line here. In this loop, we are about to change the duty from number 2 to number 12. But this time, we add this line, servo1.change duty cycle 0. 0 here represents no change. So it means that after it rotates, your servo stays still, did not move for 0.7 seconds before it moved to the next duty. So it keeps your servo 1 to stay still. We recommend you to add this line each time that you change the duty. Let's see the outcome.